Okay, this is 3-1 of Algebra. We're going to talk about inequality. So first, let's go over our different symbols. This guy, in words, is less than, or if we say it out loud, that's less than. This one is greater than. If I put a line underneath, this is less than or equal to. And same goes for my other guy. If I put a line underneath, it becomes greater than or equal to. So this is good to start out with. You won't have that on the quiz, though. You'll need to know what the symbols mean. So if we say all real numbers x less than or equal to, we're using this symbol. So less than or equal to -7. So we have x less than or equal to -7. 6 less than a number. 6 less than a number k, that's the whole phrase, is greater than, so we're using the greater than 13. So remember, less than means I'm subtracting from it. So this is k minus 6 is greater than 13. Okay, let's try our problems down here. A, all real numbers p greater than or equal to 1.5. So this is greater than or equal to. So all real numbers p greater than or equal to 1.5. So there's A. Here's B. The sum of t and 7 is less than, so I'm going to use my less than, -3. So the sum means adding, so t plus 7 is less than -3. So we're going back to at the beginning of our material, remembering what word phrases mean and trigger. So you need to remember sum, product, quotient, difference, and then our less and less than. We need to keep those ones straight. Okay, a solution of an inequality is any number that makes the inequality true. So when we were solving equations, we only had one answer. We'd only get one number, x equals 2, y equals -3. But now, since we're using inequalities, we can have multiple numbers. So if my inequality is x less than 5, any number that's less than 5 will work. I can plug in 0, and 0 is less than 5. I can plug in 2, 2 is less than 5. I can plug in -10, -10 is less than 5. There are multiple answers to an inequality. So, let's identify solutions by plugging them in. So we're going to be given a number and plug it in to see if it is a solution, if it comes out true or not. So let's just look at our got it problem here. I have 13 minus 7y is less than or equal to 6. And I'm going to plug in for y. I'm going to plug in y equals -1, y equals 0, y equals 1, and y equals 3. So 13 minus 7 times -1 is less than 6. I'm going to simplify this exactly as if that were an equal sign. So this turns into 13. -7 times -1 is plus 7. So I get 20 is less than or equal to 6. That is not true. Not a solution. Not a solution. Alrighty, let's now plug in 0. 13 minus 7 times 0 is less than or equal to 6. 13, -7 times 0 is just 0. So this is -0, or it's just a plain 13. Is less than or equal to 6. That isn't true either. 13 is not smaller than 6. Remember, with inequalities, the mouth part wants to eat the bigger number. So that's not a solution. Let's try plugging in 1. 13 minus 7, times 1. 13, negative 7 times 1 is a negative 7, so 13 minus 7. 13 minus 7 is 6. 6 is less than or equal to 6. 6 is equal to 6, so that is true. That is a solution. And finally, we'll plug in 3. 13 minus 7 times 3, less than or equal to 6. 13, negative 7 times 3 is a negative 21. 13 minus 21 is going to give me 8, a negative 8. So negative 8 is less than or equal to 6. Negative 8 is smaller than 6, so this is true. This is a solution. Alrighty. Okay, when we're graphing, so once we get it down to just the variable and one number, then I can graph it. I am going to put a dot at whatever number it is. So in this case, 1, 0, negative 3, negative 2. It needs to either be an open dot or a closed dot. If it's open, then I'm going to use the less than and the greater than symbol. Those are open circles. And it's going to be closed if I'm using less than or equal to and greater than or equal to. That's because if I'm using less than or equal to or greater than or equal to, I'm also including the number I'm talking about. So if we look at here, A is greater than or equal to 0. I'm talking about all the numbers that are bigger than 0, but I'm also including 0. So I have a closed circle. You can see there it's colored in. I have a closed circle there. Whereas if I look at F greater than negative 3, negative 3 is not going to be one of my solutions, but anything bigger than negative 3 will be. So I have an open circle there. Alrighty, so let's try graphing. Okay, so x is greater than negative 4. So I'm going to put a point at negative 4. Since it's just greater than, it needs to be an open circle. And then I'm talking about numbers that are bigger than negative 4. So my arrow is going to go this way. If it helps, you can try plugging in 0. So 0 is greater than negative 4. Since that is true, I need to go towards 0. If it was false, I wouldn't include 0 and I would go away. Here's another one. In this case, I'm talking about 0, so I wouldn't plug in 0 to try to figure it out. But I'm going to put a dot at 0. This is just the less than symbol, so again, it's going to be an open circle. I'm talking about numbers that are smaller than 0. Negative 1 is smaller than 0, so I'm going to go this way. Alrighty, again, I'm going to put a point at 3. This time I'm talking about less than or equal to 3. So this is going to be a closed circle. I'm going to color it in. And we're talking about numbers. I want to eat the n, right? So I want that to be bigger. So if I plug in 4, that is true. So I want to go towards 4. This statement here is also the same thing as n is greater than or equal to 3. I can switch my n and my 3 if I flip my symbol. Okay, now we're going to write inequality from the graph. So let's just go right to our got it problem. Okay, I have the number 3, and I'm going to choose, well, I'll choose to use x. So I'm going to use x and 3, and I'm going to stick something in the middle there. I don't have a closed circle. This is an open circle, so it's either going to be less than or greater than. So it starts at 3, and then it does all the numbers that are smaller. Sorry, it starts at negative 3. And it does all the numbers that are smaller than that, so that are less than. So negative 3 is the biggest number it ever is, so it needs to eat my negative 3. If I look at B here, I'm working with x and 0. It's colored in, so I need to do a less than or equal to or greater than or equal to. Those are my options. Oops. X is this, the 0 is the smallest it'll ever be. So I'm going to be eating my x. Alrighty, and now we're going to take real world situations and write inequalities for them. So, trail rides starting at $19.99. If it's starting, that's the lowest it can be. So $19.99 is the smallest it can be. So I have C is greater than or equal to 19.99. And if the speed limit is 8 miles per hour, that should be the fastest that I'm going. I shouldn't be going over that, even though we know people really drive over the speed limit. But technically, we're not supposed to go over 8 miles per hour, so that should be the biggest. So I have S is less than or equal to 8. Here's just a review, and I'll hand you a printout of this. Some examples with the words, the symbols, and the graph. And there's your homework.